Okay, so that was a great explanation in the last video. Let's, just to simplify the situation, sorry I'm about to sneeze, let's just assume we're in the situation that we have here where the greatest common divisor really is 1.
Okay.
So we're not too worried about that greatest common divisor part. Can you explain why these, in that case, when the greatest common divisor is 1, that once I have found a solution, an initial solution, in this case 9 and minus 6, when I add b times n to the part associated with a, I guess that's what a is associated with x.
Yeah.
And I subtract a times n to the y part. Why do I produce a new solution? This formula just kind of seemed like it came out of thin air, but why is this a new solution?
So I think it has
to this equation.
It has to do with this just being an equation of a line, and you're just moving an increment along the line that takes you to another point that is integer coordinates. If you know a point, what are we calling that? Like x naught, y naught here.
Yeah.
That has integer coordinates, and you have your line here. You just move to another point that also has integer coordinates.
Okay, yeah, that's a great actually geometric observation about what's going on here.
Yeah.
So that once you find one solution, we sort of suspect that there might be other solutions along the line.
And you can
take these steps. Yeah. Okay.
How
do I know this solution remains as, like, you're right, the intuition is we should be able to step along the line using some steps. But why is it this specific one? So what's going on here?
Let's see if we can just do it quickly algebraically out.
All right.
So we have a times x naught. A times x naught plus b times y naught is c. We already know that's a solution. Plus b times n plus b times y. That's a y, isn't it?
Yeah, why not?
Why not? Minus a times n. I want to know, does this equal c? We have an a x naught plus a times b times n plus b y naught minus a times b times n, or b times a times n, but it's the same thing, equals c. This and this are going to just subtract out, and then you're left with this plus this, which we know from up here equals c.
Yeah, cool. Now, if we put the greatest common divisor back in for a general solution, what's that doing?
Well, that just makes your step size smaller. Like this works for numbers that have a greatest common factor of bigger than 1, but this just is the minimum. It would be the minimum step size.
Okay. So if we ignored the greatest common divisor in your picture before, we'd be taking steps along the line, but it would just turn out that there were actually smaller steps that you could take.
And then you can just add the greatest common divisor in, and it's the same here, and it still just cancels or subtracts out.
Yeah, so it's actually really cool. So these, what are called Diophantine equations, they're actually really important in math. And they've been around for a long time. How can we guess that?
It's an ancient Greek name.
Yeah. And it turns out that just with some real introductory number theory, we can figure out how to solve them.
Yeah.
That's cool. All right, hey, great job this morning, guys.